Nature's most complicated and flawless creation is perhaps the human brain, with tens of thousands of researchers in the chip and AI industry trying to replicate its performance in the form of both hardware and software. Companies such as Nvidia, Intel, Apple and AMD are all trying to get ahead of each other in bringing artificial intelligence hardware into the hands of the consumer and large data centers. Nvidia and AMD are attempting to accomplish that by leveraging their already existing GPUs to handle the biggest AI workloads of today. But what if I told you that possibly soon, there's going to be another piece of hardware inside of your computer along CPUs and GPUs, and that Intel is at the forefront of developing it way ahead of everyone else? Welcome to today's episode of AI News. In this episode, I will show you what new product Intel is focusing their efforts on, in what important ways it is special and ahead compared to similar hardware which other companies such as Samsung are working on, and finally, what this could mean for the future of consumers and the chip makers which currently aren't investing into that technology. Neuromorphic computing, which mimics the brain, is thought to hold the key to AI efficiency and capabilities, according to Intel research. The second-generation Loihi processor from Intel has been made available to advance research into neuromorphic computing approaches that more closely mimic the behavior of biological cognitive processes. While Intel believes that large-scale neuromorphic AI deployment is still a few years away, the company has been investing on the hardware, software, and developer ecosystem for more than 4 years, since announcing the initial Loihi platform, and is now the first large company which actually managed to release a performant neuromorphic chip to the public. To manufacture the Loihi 2 CPU, Intel will employ their next-generation Intel 4 technology, which depends on extreme ultraviolet EUV lithography, the most complex chip manufacturing method yet developed by humans. Modern artificial intelligence software and hardware relies heavily on offline training and consumes a lot of power, yet it cannot learn on the go. Neuromorphic computing architectures promise to reduce power usage while also enabling new capabilities like automated abstraction, rapid generalization, and on-the-fly learning, which general-purpose or parallel computing architectures can't deliver with intolerable power budgets. Intel's Loihi family of neuromorphic processors is meant to look like a brain. Loihi chips excel in quickly detecting sensory input such as gestures, noises, and even scents. Artificial skin has been studied in the hopes of giving robots a greater sensation of touch. When a robot hand picks up a cup, it may detect when it's slipping so that it can auto-correct its hand position. Because it focuses more on the physical features of human gray matter, neuromorphic computing differs from artificial intelligence, a breakthrough computer technology built more loosely on how brains learn and respond. It varies from traditional chips in a number of ways. For example, instead of storing data in a large bank of typical computer memory, Loihi 2 stores data in tiny bits scattered over its mesh of neurons, and it doesn't have a central clock running to synchronize processing processes on the chip. Low power consumption is also a feature of biological gray matter. Neurons, which make up roughly 80 billion cells in the human brain, are linked together in complex electrical communication networks. When a neuron receives enough input signals, it fires its own signal to neighboring neurons. Everything from recognizing Abraham Lincoln to riding a bicycle is made possible by the structure of signal connections and flow. The process of learning entails making and strengthening those connections. Intel's device is made up of 1 million digital neurons that may be linked in any number of ways, thus creating a digital blank slate. Configuring the correct connections between neurons is required to make it operate. When input data enters the chip, it triggers a burst of activity that travels through the chip's linked neurons, finally producing an output. On average, each neuron is linked to 100 other neurons, however some may be connected to as many as 10,000. According to Intel, the chip's flow-like architecture means it uses extremely little power while idle and can process data very rapidly on demand. Intel also says that programming neuromorphic devices is a difficult task. They have also published an open-source software framework called Lava to help researchers with the process. Intel has a similar aim of commercialization. Intel needs to set the framework for billion-dollar industries, whereas startups like BrainChip can get products to market for specialized use cases. That takes time, and it necessitates the use of excellent tools. Intel unveiled its open-source Lava software development platform, reiterating its commitment to community development. Lava will attract a large number of developers, resulting in greater possibilities and learning. Lava will allow academics and application developers to build on one another's efforts and converge on a shared set of tools, techniques, and libraries as an open, modular, and extensible framework. However, Intel is not alone in feeling that the neuromorphic method merits additional study on the competitive front. RAIN Neuromorphic is working on an analog learning chip that can scale in 3D using 3D RRAM, which can be manufactured with tools similar to those used for 3D flash memory chips, and leverage equilibrium propagation, which could be 1,000 times more efficient than today's best-in-class digital backpropagation with its expensive global learning rule. BrainChip Holdings, a publicly listed business, has both a SoC and IP license for its neuromorphic technology, which it claims can scale down to milliwatts for edge applications. Loihi 2's neurons update at a rate of 4 to 22 times quicker than IBM True North's. And, like multiplicative amplitudes, propagation delays, nonlinear synaptic responses that increase algorithmic capabilities, and even weight modifications, Loihi 2's synaptic operations include key differentiators that enhance model application and precision. Intel has not yet published information on power usage. The creation of a 1 million neuron brain-inspired processor is only the beginning. Loihi 2 introduces increased learning capabilities, programmability, and scalability, allowing for more functions and applications. Although there is still more work to be done in terms of software and future processors with greater capacity for larger models, I am certain that analog and neuromorphic computing will have a substantial influence on the capabilities and, more crucially, the cost of large-scale AI. While the meaning of this idea might be a little difficult to grasp, understanding how neuromorphic computing works will help you grasp its essence. Let's start with how neuromorphic computing works. The installation of artificial neural networks, which consist of millions of artificial neurons, is the first step in the operation of neuromorphic computing-enabled devices. These neurons are comparable to those found in the human brain. Layers of artificial neurons send messages to one another, allowing a computer to function and work like a human brain. These electric impulses, also known as electric spikes, transform input into output, allowing neuromorphic computing machines to function. Spiking neural networks are responsible for the transmission of electric spikes or signals. This spiking neural network design also allows an artificial computer to act in the same way as a human brain and execute tasks that people can perform on a regular basis. This can include visual recognition, data analysis, and a variety of other activities. In comparison to regular computers, neuromorphic computing devices utilize less electricity since these artificial neurons only require power when electric spikes are transmitted through them. Neuromorphic computing devices mimic the neurobiological networks seen in the human brain, allowing them to execute tasks quickly and effectively. Neuromorphic computing has enhanced technological advancements by allowing computers to function in the same way that the human brain does. Computer engineering in the past resulted in the creation of conventional computers that required a lot of room to operate. Computers that use neuromorphic computing, on the other hand, take up considerably less space and have the capacity to function quicker and better. Neuromorphic AI computing is an important area of AI because of its sophisticated technology. Neuromorphic computing has paved the way for improved technology and quick advancement in computer engineering by allowing artificial computers to behave similarly to the human brain. Neuromorphic computing devices have changed the way computers function as well as allowing for fast expansion. Computers can now perform nearly anything, from data analysis to machine learning algorithms. They have become the leaders of AI through inducing information processing technology, which has resulted in the third wave, according to many. Scientists have drawn comparisons between the third generation of AI and the human brain's skills such as data interpretation and adaptability. Neuromorphic computing has enhanced the process of information processing and enabled computers to deal with better and larger technology thanks to one of machine learning's approaches. Interested members of the Intel neuromorphic research community can now use Intel's cloud to access operational Loihi 2 hardware. The chip manufacturer is already testing a single-chip Ohio Gulch system which is powered by a graphics card and intends to release an 8-chip Kapoho point system soon. Loihi 2 will not appear on your phone or laptop. Instead, it's aimed at manufacturers, government labs, and universities researchers. The Deutsche Bahn railway network in Germany is putting its train timetable optimization system to the test. The CPU is designed for activities like sound processing and gesture detection, but it uses a lot less power, according to Davies. So what is your opinion on Intel potentially outmaneuvering the competition by investing and releasing such a new product category Sun much sooner than everyone else? Do you think this will pay off in the long run? Please tell us your opinion in the comment section below. I would love to hear what you have to say about it. Thank you for watching AI News. We consistently report on the newest technologies that are shaping the future of our world. We'd appreciate you subscribing and watching our other videos. See you around and take care.